G'day, science lovers, and welcome. Have you ever looked up at the night sky filled with its countless twinkling stars and felt a profound sense of wonder? It's a truly magnificent sight, a vast, dark canvas sprinkled with the light of distant suns. You might think about how big it all is. You might wonder what's out there. Are we alone in this cosmic ocean? But have you ever stopped to think about something even more fundamental? Have you ever considered just how incredibly lucky we are to even be here, asking these questions in the first place? It's a thought that can send a shiver down your spine. The fact that we exist at all is, when you really dig into it, one of the most astonishing miracles in the known universe. Think about it for a moment. Our existence depends on a fantastically long and delicate chain of events. It's a cosmic lottery, and we, my friends, have won the grand prize. For life to arise, you need a planet. That planet needs to be in the right spot, not too hot and not too cold. It needs liquid water. It needs a stable star to orbit. That star needs to be of the right type, not too volatile, not too short-lived. That solar system needs to be in a safe part of a galaxy, away from all the cosmic rough and tumble. But the chain of luck goes much, much deeper than just our local cosmic neighborhood. It goes all the way back to the very beginning of everything. The very laws of physics that govern our universe seem to be perfectly set up for life to emerge. It's as if someone, or something, tweaked the dials of reality with incredible precision. If you change any of the fundamental constants of nature, even by a tiny, tiny amount, the universe as we know it would be unrecognizable. It would likely be a sterile, empty void. No stars, no planets, no galaxies, and certainly no curious humans staring up at the sky. It's a mind-boggling concept. We are living on a knife's edge of cosmic possibility, a delicate balance of forces and values that make our world and our lives possible. This isn't just a philosophical musing, it's a genuine scientific puzzle that has intrigued some of the greatest minds in physics and cosmology. Why is our universe so welcoming to life? Is it just a happy accident, an unbelievable stroke of good fortune in an endless cosmic casino? Let's call this puzzle the Goldilocks Enigma. You all know the story of Goldilocks and the three bears, right? She tried the porridge that was too hot and the porridge that was too cold, but she settled on the one that was just right. Well, it turns out our universe is a bit like that perfect bowl of porridge. So many of its fundamental properties are not too this and not too that, but are balanced just right for life to cook up. It's an idea that gets more and more mysterious the deeper you look into the physics of it all. Take gravity, for example. It's a force we all experience every single day. It feels pretty strong, especially when you drop your toast butter side down. But in the grand scheme of cosmic forces, gravity is astonishingly weak. It's billions and billions and billions of times weaker than the electromagnetic force that holds atoms together. If gravity were just a tiny bit stronger, stars would burn through their fuel much faster and hotter. They would live for only a few million years, not the billions needed for complex life to evolve on any orbiting planet. The universe would be a flash in the pan, over before the party even got started. Now, what if gravity were a tiny bit weaker? Well, then the opposite problem occurs. The gentle pull of gravity wouldn't have been strong enough to clump matter together after the Big Bang. The primordial gas clouds would have just dissipated into the void. Without that clumping, there would be no galaxies. No stars would ever light up. No planets would ever form. Consider the force that binds atomic nuclei together, the strong nuclear force. If it were slightly weaker, only the simplest element, hydrogen, could exist. No carbon, no oxygen, no complex chemistry at all. If it were slightly stronger, stars would have burned up all their hydrogen fuel very early in the universe's history. The universe's fine-tuning is like a symphony orchestra, where every instrument must play in perfect harmony. If one is even slightly out of tune, the entire performance becomes a discordant mess. So, how did our universe get its pitch-perfect cosmic symphony? So, we've seen that our universe seems to be exquisitely fine-tuned for our existence. It's a puzzle that has left scientists scratching their heads for decades. How do we even begin to talk about this without getting lost in philosophy? Well, back in the 1970s, a brilliant astrophysicist named Brandon Carter decided to give this idea a proper name. He called it the Anthropic Principle. The word anthropic comes from the Greek word for human. So, at its core, it's the human principle. It's a way of acknowledging the very strange and powerful connection between the laws of the universe and our own existence as observers within it. Carter wasn't trying to say the universe was definitely made for us. He was more of a cosmic detective pointing out a very important clue. The clue is this: our observations of the universe are inherently biased by the fact that we have to be here to make them. It sounds a bit like a brain twister, but it's a profound point. Here's a simple analogy to make it clearer. Imagine you're a fish, a very clever philosophical fish. You spend your days swimming around, and you start to notice something amazing about your world. You notice that your entire environment is filled with liquid water. You might think, wow, what an incredible coincidence. The entire world is perfectly designed for creatures like me who need water to live. The fish might develop grand theories about how the world was purposefully made to be wet, but the fish would be missing the point. It's not a coincidence. It's a selection effect. The fish can't observe a world without water, because it wouldn't be alive to do so. Our situation as humans in the universe is remarkably similar to that of the philosophical fish. We look around and see a universe whose physical laws and constants are perfectly suited for carbon-based life. But the Anthropic Principle reminds us that we are the fish. We are adapted to our water, which in this case is this specific set of physical laws. So, we have these two competing principles, the weak and the strong. The WAP is modest, logical, and widely accepted as a valid scientific consideration. The SAP is bold, speculative, and highly controversial. The difference between them is not just a matter of semantics. It represents a fundamental divide in how we approach the deepest questions of cosmology. The weak Anthropic Principle is often linked with the idea of the multiverse. If there is an infinite or near infinite number of universes, each with its own random set of physical laws, then it's no longer surprising that at least one of them, ours, would have the right conditions for life. The WAP then becomes a simple probability argument. On the other hand, the strong Anthropic Principle pushes us in a different direction. If our one and only universe had to be this way, it suggests that our current understanding of physics is incomplete. It implies that there might be some as yet undiscovered law of nature that requires the constants to have their life-permitting values. Let's step through a cosmic looking glass into universes that could have been. What if the dials on that great cosmic control panel were set just a little differently? Imagine a universe where the fine structure constant is just 10% larger. In this reality, the electromagnetic force would be significantly stronger, but this would make atoms unstable. You would lose every element except hydrogen. The periodic table would stop at hydrogen. Now let's explore a two-dimensional universe, a flatland cosmos. What would life or even basic physics be like in such a place? For a start, complexity takes a massive hit. In our three-dimensional world, neurons can make connections by going over and under each other. In a two-dimensional world, this is impossible. Any connecting wire would act as a wall, dividing the plane. What if gravity was 1,000,000 times stronger? This universe of crushing gravity would be a fast, violent, and ultimately short-lived place. Stars would form quickly and be far more massive, but they would burn through their fuel in just a few million years. Any structure taller than a few molecules would collapse under its own weight. Let's zoom in from the grand cosmic forces and look at a single element essential for life: carbon. Carbon is cooked up inside the fiery hearts of dying stars through the triple alpha process, where 3 helium nuclei have to fuse together. But getting 3 things to collide at the exact same time is incredibly unlikely. The great astronomer Sir Fred Hoyle realized that this process wouldn't work fast enough to produce the carbon we see. He predicted that carbon-12 must have a very specific resonance, a specific energy level that perfectly matches the combined energy of beryllium-8 and helium nuclei. Later, nuclear physicists found it exactly where Hoyle said it would be. But that's not the end of the story. Just as there's a resonance that helps create carbon, there is a convenient lack of a similar resonance in oxygen. If there were a resonance in oxygen, then as soon as carbon was created, it would immediately fuse with another helium nucleus to become oxygen. The laws of physics seem to have been rigged with one resonance precisely tuned to boost carbon production, and another conveniently absent to prevent it from being destroyed. This is where one of the most mind-bending ideas in science comes into play: the multiverse. What if our universe isn't the only one? What if it's just one bubble in a vast cosmic ocean of other universes, each with its own set of rules? The eternal inflation model suggests that while our patch of space settled down, other regions are still inflating, constantly spawning new bubble universes. Each time a new bubble forms, the fundamental constants could be set to completely random values. Most would be sterile, dead-on-arrival duds. But in a cosmic lottery with an infinite number of tickets, every possible combination is bound to come up eventually. It becomes statistically inevitable that a few universes would have just the right conditions for life. This completely reframes the fine-tuning problem. Our universe's life-friendly laws are no longer a shocking miracle that demands a special explanation. Instead, they are the result of a simple selection effect on a grand cosmic scale. We find ourselves in this specific universe for the same reason we find ourselves on a life-friendly planet like Earth. Hold on to your hats, because we're about to dive into an even stranger possibility. What if the fine-tuning isn't the result of a cosmic lottery or deeper physics? What if our entire reality is not the base reality at all? What if we are living inside a massively complex computer simulation programmed by a far more advanced intelligence? Think about the video games we create today, becoming more realistic with their own internal physics. Now imagine a civilization millions of years more advanced than us. Their computational power would be beyond our wildest dreams. They could run ancestor simulations or create universes for research, art, or entertainment. In this scenario, the fine-tuning has a straightforward explanation. The laws were written this way by the programmers. The constants were set to create a universe that would give rise to complexity, stars, planets, and eventually life. The just right conditions aren't coincidence. They are deliberate design choices typed into the cosmic source code. The debate surrounding the Anthropic Principle is far from over. It's one of the most active frontiers in fundamental science, where physics, cosmology, and philosophy collide. The fine-tuning problem has not been solved, and it continues to be a persistent mystery that some of the world's most brilliant minds are grappling with. It's a clue, perhaps the most profound clue we have, that our understanding of the universe is still woefully incomplete. There is something fundamental about the cosmos that we are missing. The fine-tuning problem is a cosmic breadcrumb trail, and while we don't know where it leads, the journey to find out is one of the greatest adventures in human intellectual history. So after this whirlwind tour of cosmology, physics, and philosophy, we find ourselves right back where we started, staring up at the night sky, but perhaps with a new and deeper sense of astonishment. We've journeyed from the simple observation that our universe seems perfectly suited for us, to mind-bending possibilities of infinite parallel worlds and simulated realities. What does this mean for you and me? It means our existence is far more astonishing and precious than we often realize. Whether by incredible luck or profound design, we are living in a universe that is a masterpiece of cosmic engineering. The atoms in our bodies were forged in the hearts of dying stars, whose existence depended on the delicate balance of fundamental forces. We are not separate from the universe, we are a part of it. We are, in a very real sense, the universe's way of thinking about itself. The Anthropic Principle serves as a constant reminder of the mystery and privilege of our own conscious existence. It encourages us to stay curious, to keep asking the big questions, and to never lose our sense of wonder. So, the next time you look up at the night sky, don't just see the stars. See the incredible chain of cosmic coincidences that allowed for those stars to exist. See the fine-tuned laws of physics playing out across billions of light years. See the mystery of your own existence reflected in that vast, dark canvas. Remember that you are part of a grand and beautiful puzzle, one that we are only just beginning to comprehend. Keep asking questions, keep learning, and most importantly, keep looking up. Thanks for watching.